Hello. In this video, I'm going to go over some of the Excel, um, some of the ways of setting up Excel to help you with part 6 or activity 6. Okay, so in our previous video, we had worked out that if you take the difference of energy between, say, the R0 and then you subtract the energy of the P2, notice I've made a column of J values. So I have my R0, my R1, my R2, um, my P1, P2, P3, P4. I just haven't completely filled in my chart, so I haven't gone through the entire band. But I can take the R0 minus the P2, hit enter, and then we'd worked out before that that's equal to 6 times B0 minus 36 times D0. So maybe we'll put our symbols up here, and then we'll just know that what we're meaning here is that this 62.65 is equal to 6 times B0 minus 36 times D0. And then we also reasoned out that we can copy down, if you will, do the next transition, do the R1 minus the P3, and we had determined that that was equal to 10 B0 minus 140 D0. Now, one of the things you can do is a system of equations using Excel. This isn't really a math class, so I'm not really interested in who can figure out how to click the cells in the right way to solve for B0 and D0 given the system. So one of the things you can do is head over to Carmen. I have a system of equations solver file that you can download. Only thing you'll want to do is actually make sure to download it as opposed to just open it. So we'll download this, and we'll just open it with Excel. Depending on the browser you're using, this may be easier or harder than other browsers. One of the things that commonly happens on PCs, I'm on a Mac right now, but something on a PC, a lot of times this opens up in a read-only file, and sometimes what you have to do is just do a file save, or a file save as, I'm sorry. And then that'll prompt you to actually save it as an actual file so that you can put it wherever you want to put it and then save it as a non-read-only file. So I'll just throw it in my folder. I give it a weird name. But one of the key things that you can do is just more or less copy the value. See what this system, there's like, it's kind of showing you that if you have a system where M is equal to AX plus BY and N is equal to CX plus DY, and then you can solve for the value of X with that set of equations, and then the value of Y with that value of equations. So this is evaluating X, and this is evaluating Y. So what I'm going to do is I want to copy them from down here just because this gets you in the thought of, okay, we're going to have multiple systems that we solve. And I'll talk about that in just 1 minute. So we'll come over here, and we're going to paste here. The only peculiar thing is it takes it brings over the font as well. So you might see some mixed match font, but that's okay. But make sure to do a normal paste so that you paste the actual equation so that you actually do the proper arithmetic to solve for B0 and solve for D0. So sometimes this is confusing when you see that you're determining B0 and D0 here and here, and that B0 and D0 here are really just more your placeholder for 62.65 is equal to 6 times B0 minus 36 times D0. 104.34 is equal to 10 times B0 minus 140 D0. So now I can copy this down, and then I can do like the next system, but the problem is I can't exactly copy down here yet because I haven't told the program anything about predicting what cell should be here. So let's go back to trying to figure out, well, how was it that I figured out that it was 6 minus 36? And how did I figure out it was 10 minus 140? Can I enter using equations so I can more or less make the arithmetic automatic or automated? And so the way that we had done this was by taking, if you remember, the first system was the F0 of 2 minus the F0 of 0. So it was the J times the J plus 1. Remember that multiplication symbol is really important. So whenever you open a parentheses, do the multiplication. Excel, for some reason, is pretty silly and doesn't realize that. And then it's subtracting the 0 times 0 plus 1. Now, for the first one, we could have left this out. Like, we didn't have to put this in because it's just going to work. Like, this a2 times a2 plus 1, that's just 0. So we didn't need it to calculate 6 correctly, but we needed to calculate 10 correctly. And if I copy down here, it almost worked. What did I do? Incorrectly minus... Oh, yeah, I just simply haven't put the next number down yet. So I forgot to put the 4 in. Okay, so as long as I put the 4 in, and I have a complete or semi-complete file, then this calculates correctly. Okay, now how did I get the minus 36? Well, I got the minus 36 by taking the minus and then j squared times j plus 1 squared. And then minusing 0. But I'm just going to hit enter to make sure that this is working right. So I'm going to want to put parentheses so I get minus 36. And then I'm going to then do the arithmetic for minus 0 times 0 plus 1 squared. In fact, I missed the squared. So it's j squared times j plus 1 squared. Close the parentheses, hit enter. So that looks good. Now, sometimes I do this wrong. And I did quickly keep a sign minus, and maybe it should have been plus. Okay, I did do it correctly. So the, like if you do the multiplication signs or you're not thinking your plus and minuses correctly, you mistakenly put a plus here, then you get a different number than you expect. My point here is going to be, if you know that it was supposed to be 6 and minus 36 and 10 and minus 140, you'll catch this mistake. Okay, now it should be good copying down. That is the right number, and if you weren't sure, what you would want to do is just take the f0 of 4 minus the f0 of 2, so you're just doing the arithmetic for plugging 4 into the expression, so 4 times 5 times b0 minus 4 squared times 5 squared times b0, and then subtracting, plugging in the 2. So subtracting 2 times 3 times b0 minus 2 squared times 3 squared times b0. And numbers get to be pretty big if we were to continue downward and have a couple more j values so we don't run out of cells here. To give you a sense of how quick these are going to sort of blow up, is that the d0 term is going to grow to be pretty big as we keep going. And likewise, you're going to have more p and r branch values in your cell because you would have made a table of all the p and the r branch peaks that are observable. Okay, now watch how simple this is going to be to calculate the next system of equations to solve for b0 and d0. I'm just going to copy down. That's all I got to do. What you'll find, generally what you'll find is that the b0 values are pretty consistent, 10.4 or so, and then the d values are going to be a little bit more subject to some noisiness. So the d values you're going to see aren't as precise. You're going to see a little bit more variation in those values. But that's quite simply how you determine b0 and d0. And then when you come to needing to find b1 and d1, one of the things you might do, let's see if we can copy and paste this. No, that doesn't work. What we might do, probably easier thing to do, is to copy this into just a new worksheet. Just zoom in so we can see. And so when we're changing the arithmetic and changing our approach for finding b1 and d1, you might recall that the biggest difference here was that we had taken the r1 minus the p1, and that we found was equal to 6 minus, 6b1 minus 36d1. And we had found that taking r2 minus p2 was equal to 10 minus 140, so 10b1 minus 140d1. So we can solve this system, and you can see the first determination of b1 and d1 through the first two systems here is equal to about 10.14, and you can see the d value accordingly. This value here, I just haven't recorded the next r branch peak, but you can fill those in and accordingly determine the range of values for b1 and d1. Then in the end, you're just going to take an average. You're going to take an average of the b0s for b0, an average of all the b1 values for the b1. If you find any of the values are particularly far away from the others, or if you find a couple are off, it probably means that a number is transcribed incorrectly. So if you record a value and correctly say you record this as like 28, 61 instead of 21, you're going to notice, by a pretty big mistake being made in the value. So if you see something off in your determinations, look for a transcription error in determining your PNR branch peaks. Okay, I think that's all for this video.